While my other team members worked on the metrics with the Trek eval tools provided, I went ahead and worked on the corpus. Both of these files did not communicate with one another as the Trek eval was ran through terminal commands, while the Trek car tools were ran through Python commands. One displayed the metrics of the importance and relevance of each paragraph, while the other displayed the contents of what the paragraph says, its page ID, and so on. The first slide shown here displays the Trek car tool file contents in which I downloaded. From here, I went into the Python 3 folder and then the Trek car folder. Here's where I practiced the code for the read data Python file. Everything after this file are files I've added on my own, which will be discussed later in this video. Now, on to discuss the corpus. The corpus consisted of various files, as you can see, which are encoded versions of articles, documents, queries, and paragraphs. My task was to find a way to decode these files and display either the text itself, the number of headings, page ID of each article, and so on. The dataset were first found on the Trek car website, where each dataset consisted of a number of different exports such as annotations, which are also called page files, containing full Wikipedia pages and their contents, paragraph files, containing only paragraphs disembodied from their pages, outline files, only the section structure of pages and no textual content. The image shown here is the corpus file extracted using the terminal commands. Within this file, each QRL file has a different topic such as paragraph, outline, and article. This relates to the code which is shown in the next slide, which I'll display after I'm done explaining. From the website, there were various corpuses that we could download ranging from a mere 200 megabytes to 16 gigabytes. I chose the test 200 file as it was mentioned within the example itself, and it consisted of low memory to download. Looking at these files, the contents of this file, one can see that it wasn't just one mass file like the run judgment file that we received that had more than 10,000 lines of code. No, these are all CBOR files. CBOR stands for Concise Binary Object Representation. Here, each file represents different binary representations on whether the file is an entity, paragraph, heading, and so on. Some of these files, such as test.test200.cbor, were copied and pasted in the Trek car folder mentioned before. Now, lastly, this is the read file itself. Here is where I wrote the code that went through the project to output a text, ID number, and so on. Each class within the read file Python file corresponds to the certain QRLs that were downloaded. For instance, to list the page IDs of pages in the page file, one might write a code consisting of a for loop that iterates through each annotations of the CBOR file, then print out the page ID. Likewise, if one wanted to read the paragraph, as I did in the terminal command listed over here, one might write a for loop that iterates through the different paragraphs and then print out the text itself.